Yo, what's up? Good morning. Let's start because I'm hoping of finishing the reflection today. So we're just going to jump right in. We're going to jump right in just after I say where we're at. So we managed to get an acceptable screen space reflection implemented. It came with its banding artifacts and some small minor other stuff that we can, like artifacts that we can minimize. The biggest downside with that implementation is that even though you change the parameters so you gain improved visuals, but you lose performance, we didn't really get that good of we didn't get a good enough result given the performance we got. So like when we have screen space reflection like this on a big area like this, I want to land over 200 FPS here in the editor, or that's what I'm aiming for at least. But yo, what's up, Harukanan? Good morning. But at the end of yesterday's stream, we implemented we did some changes to the algorithm in such a way that we, instead of comparing points, we compare interval. And I know that like some implementations of screen space reflections does it by 1 point, but I think I've seen others that do it. I haven't seen interval, I don't think, or I have seen interval but between previous and current point, not current point offsetted in both directions. But I'm pretty sure a similar solution exists out there. But so the idea is to continue with that today, hopefully get a good enough result, refine it, and then call it quits on reflection and move on. I would also like to, right now we implement this as a pure screen space reflection shader. In the future, I would like to implement this reflection stuff as just a function pretty much. So we're going to create utility reflection or just reflection.hlsl, and then we can include it in every shader that needs reflection, basically. Yes, but let's continue. So what we're seeing now on the screen is I did some experimentation with dot product just before we quit yesterday, because I want to figure out, basically we always work with two rays in screen space reflection, or you can see it as one ray but represented in two different spaces, because that's what it is. It's one ray originally defined in view space, and then it's that same ray defined in screen space. And depending on the angle between these two, because the screen space ray only moves in the X and Y directions, while the view ray moves in the X, Y, and Z. So it's the same ray, but one is in 3D and the other one is the projected representation of that one. And when you have it like that, you can get, so moving a tiny step on the screen space ray, like 1 pixel, might actually correspond to moving 5 world space units for the view ray. So let me draw this. Mostly for me, but maybe it can help someone understand it. So I can start by just showing what we're doing. Okay, so if we have the camera here, and then we have the screen here, and if we have a ray, fuck, this is hard. Drawing in 3D. But if this ray in world space is like this, the ray on the screen is actually just like this. So moving one step here, so 1 pixel here, might actually correspond to this section of this ray. So we just move a tiny bit here, but we actually move a big distance here. So what we do now is we step through this ray. So first point, second point, third point, fourth point, and so on. We do the same thing on this one. And what I want to do then is, when we check this point, for instance, we add a offset here and an offset here. So we actually check the depth on the ray here and the depth on the ray here. But when we read the depth value from the scene, we do it for this point, so the pixel point. So we're going to get one depth here, depth scene, let's call this one D1 and D2. And then we figure out which one of these are the smallest, and then we do a comparison that is, we also set the smallest to D1 and DS D2. So if this depth is bigger than this depth and smaller than this depth, then we have an intersection and we return 1 currently. But the idea later on is that we start from this point and then we step through until we find a very good intersection, and that's the pixel we return. So it's a very broad and cheap walkthrough here, and then we do the more costly one if we find a interesting intersection. It should be pretty cheap. Calculating this one is just a lerp. Calculating this one is a lerp. This one is a texture read, but that's okay. This one is actually going to be 2 texture reads eventually, because we're going to read the outline texture as well. I'm still not 100% sure this is an airtight way to do this, but I think it makes sense. I'm pretty fucking sure it makes sense. Because that would be if we have an object and the ray intersects the object here. And then if we take this point, for instance, and we step back, we find that we are in front of the object here. We step here and we find that we're behind the object here. That means that this point is inside the object. Or it means that this section intersects with the object. So the current result we get from this is not without its own artifacts right now. We have this one. We have like banding if we look at a very steep angle like this, and the idea here is that the dot product, so basing the step length here, or basing the step length of this one on how the angle between these two rays will help with that. We also have an artifact when we look from the top like this. You can see here that we get a weird drag for this one. And I think that's a similar issue. We're going to solve that with the dot product as well, or minimize it at least. And what's good with this one is that, let's see, plane, what do we have? We get pretty good results at a pretty good performance. So we can see here that we get banding here, but it's not too bad. We're at 250 FPS, 200 if we look like this. It's going to be a little bit worse when we introduce the second pass, but I think this is way better. So now we just need to figure out how to handle these artifacts and these artifacts. I'm a little bit worried about this banding we see here. I don't know the cause for these on the top of my dome. And also, didn't we have, if we do 10 here, yeah, we have this issue as well. But yeah, hopefully we will get rid of those today, implement the second pass, and finish up the reflection. But yeah, it depends on if some other ideas pops up or something other we want to explore. I don't know, but that's the plan at least. So right now we basically have, what is it, two, honestly, I think we don't need to. The reason I want to do it with this offset instead of taking maybe. Like, instead of interpolating 2 points like this, we could, like I've seen, we're going to keep this in mind and maybe revert to it. So we always keep track of the previous depth. So when we calculate this depth, we use these two. So the current and the previous ones, just like we do D1, D2. But that would tie these 2 points to the step length, and not the step length of this ray, but the step length of this ray. And I wonder if that's something we want to do or not. I think maybe. Because right now we rely on, what do we have? We have we have step length, we have something we call jitter right now, but I would call it like offset or something like that, and that's this distance. And then we have, is that actually the only two? Point A, point B. We have thickness as well. Thickness is pretty much an offset we add. So how close, or should I put this? How close can these be? Or you could pretty much see it as a margin of error here, because what we do is we take minus thickness for D1 and plus thickness for D2. Yes. I want to try and do, let's see, array offset point SS depth difference. I think I want to split this one up as well. I'm gonna do create screen space array. Get array point. get ray point SS. Get ray depth VS float get ray depth SS. Or fuck it, I don't think we need this one actually, but we do need this one. Okay. The other way around here is point within screen bounds. Fuck it, let's return this. Okay, good. Because I'm wondering if I might just want to do this here instead. So we're gonna do this. And we're going to start using previous depth VS, current depth VS. We're going to start using these. Oops. Calculate or get ray depth VS ray 0. Current depth, yeah, we can just set it to previous step count is equal to step length. We want to start at 0 here. Ray previous mispoint SS. So what we do in this while loop then is, first of all, we calculate the next point. So current point SS is equal to get ray point SS ray, and then we want to calculate the offset, so we're going to do float offset is equal to step count times step direction. So then we have current point, and then we want to do if is within screen bounds. If it's not within screen bounds, current point SS. Then we do return 0 for now, or actually let's do float t is equal to inverse lerp ray current point SS. If t is bigger than 1.0, if we get to this point, that means that we have a new depth. So we really only care about let's see here. Like we have two types of intersections, and I think, okay, I wonder, we could have one that is intersections from behind and its intersection from the front we care about, I think. But let's take both into account now, I think. So then we calculate current depth Vs is equal to get ray depth Vs ray T, right? pretty much want to do this, but we're going to do it with previous and next point instead, so we don't need to do two interpolations here. But I wonder if we want to do this comparison in a little bit of a different way. Probably later on. For now we're just going to do this. Current depth Vs. And then we do let's do and then I want to do the thickness comparison. I'm a little bit so now we might get back to the same problem if we do thickness here. We might go below the surface for the first point, and that sucks. But let's see if we can get this to work first. If depth bounds.x is less than or equal to, or minus thickness is less than or equal to float scene depth Vs is equal to but we want to sample it at current point SS. And scene depth Vs is less than or equal to depth bounds.y plus thickness. Then we return 1. Otherwise we want to continue with this while loop. We have already incremented this and this, or we do it first. So the only thing we need to do is set this one. In fact, do we use previous point SS right now? No, we don't. In fact, do we need... I don't think so. We just want to set these. Or actually just this one. Something like this. And not projection params, we want to do subbuff params. Yo, what's up, Riz? Oh yeah, actually, we want to sample and then we want to use this one. So what do we have? Now we only rely on step and thickness, right? C++, no, this is HLSL. Currently, and then the game logic we do in C#. Okay, we can see here that this one, we get this here, red, we go out of screen bounce, that's good. Black, we go out of array. So why do we get... I want to try and take thickness down to 0. And let's see here. What have I missed? Scene depth, current point. We step, add safe stop. Step count times step direction. Step direction hasn't changed. Current point, get ray point SS ray offset. Ray start SS plus offset. I think that's good. Is within, yeah, this one works and this one works. Current depth VS, get ray depth VS. Ray and float T. Start VS, end VS. Saturate. I don't think we need to do this one right now, at least. I don't think it's gonna help, but yeah, we don't need to do it. So it could be this one. What do we have? Previous depth VS, current depth VS, and then we flip them if current is less than previous. It should be pretty much exactly the same as this one, right? We have thickness at 0 currently. We have 20, 10. We set previous depth to current here. What am I missing? I wonder about this one. Previous depth vs current depth. I think the normal assumption to make here is that this one is less than this one. Most of the time we're gonna move away from the camera with the rays. These two look to be all right. Actually, we never get this one. Interesting. Red, black, white. We should be able to get this if we do. Here we go. There we go. But we get white instead of blue in most cases. Okay. So something here is wrong. I'm gonna step through it real slow just to make sure. So get ray depth VS. We send in the ray and T. We do negative in front here. Do we need in front of everything? Float T. Start VS and VS and VS start VS. I think this one should be correct. Previous depth VS though, what do we do here? Get ray depth VS, the ray, and we do 0 at T. Current and previous is the same, but we change that here. Should also be okay, I think. So what the fuck? Can't we do this because if we take a ray that hits here, for instance. Oh! thickness is 0, so initially this should be false. But do we have... we don't have a... there should pretty much be no point for this ray where scene depth is in the middle of previous and current point. So what the fuck? Get ray point SS. Did I double check this one? I don't see it. Sample scene depth, current point. We do the same thing here, but we do it with previous point, so I don't understand what... it's pretty much exactly the same as this one. To the T. And this one still worked. I wonder. Yo, what's up, Luke? Unity question mark. Unity, yes. I don't really see where this one... very weird. Did we have... Could we get... Nah, we shouldn't need to saturate this one, I don't think. Yeah, looks to be all right. What the fuck? And when we do get ray depth VS, we do flip the sign, right? Yeah, we do. How do kind of know there we just did a synchronous what the fuck, but completely unrelated. Love it, love it. We're gonna do this. We're gonna test the old one again, see if it still works, because honestly, I have no idea why this wouldn't pan out. So let's do this. And then we do calculate CMU different for way. And what do we have? We have ray, step count times step direction. And then we want to have float depth difference. I think we can just do this and float 2. And then we do return if depth difference is less than or bigger than 0. Return 1. Okay. And that's because this one is based on jitter and also thickness. Yes, and also on thickness here, 0.1, 0.1, 0.1, 0.1. Luke, cool GitHub portfolio. Thank you, appreciate it. Okay, close, but no cigar. At least we get reflection here. That's good. Jitter. What have I done? I just wanted to rewrite this in a cleaner way that would open up for much more experimentation, and I thought I did the exact same thing, but we're getting different results. But yeah, that's how it goes. Did I screw up something initially? I don't think so. Actually, we should be able to go with thickness 0, and jitter is the biggest one. So jitter leaves us with pretty good reflections for this little square we get here. So yeah, this one returns. Oh yes. Or actually, thickness is 0. Yeah, jitter. Okay, so that's not the problem. Oh, beautiful. This is beautiful. So depth difference. Here we want to do it. Yeah, of course. Start end. Could it be, let's see here, ray point SS, get ray point SS. This one is correct. Have I changed some property that I shouldn't have? Because I'm starting to think that like everything looks okay. But obviously something is very wrong. Okay, the problem is that this one returns this one returns true, so 1 in too many cases where it shouldn't. And we have two variables here. We have thickness, which is the third one, but this one is 0, so we don't need to think about that one. But we have scene depth in view space. So we sample scene depth, we do it from the current screen space point. So this could be one thing that is wrong. One sec. Okay. And then we have point A depth, which means that pretty much something else here can be wrong. We're just gonna do it like this. We're gonna do let's go back, and then we do current depth VS. We're gonna do fuck it, return I want to check the depth here, but if we check the depth here, if we just return the depth here, we're gonna do it very early, but it might be nice to do it. Just double check, see that it's okay. So we do this. Ooh. Ooh, yes. We want to do Y Z here. And then I want to do the same for, so this one looks okay. I'm going to do scene depth here. This one looks okay as well. So that doesn't help me. What did we have on these? Okay, so that doesn't help us. The DAC, what's up? Ooh, does this help us? Yeah, we get some weird projection shit going on here. Okay, good to know. That makes me wonder if this one is actually done, or this one is actually done correct. Luke, curious to know your reasons to not use screen space reflections, probes, etc. Mainly, it's screen space reflection we're trying to implement right now, and I want to do it myself because we're gonna do we're gonna extend it, and mostly we're going to extend it to support these outlines. So that's the main reason for implementing it ourselves. Probes, would love to use probes, but we're not going to be working with a static environment. So probes is perfect when you can do a lot of pre-baking, right? We're not going to be able to do a lot of pre-baking because we're going to have a garden or environment that the player can change in real time at will, pretty much. So change the terrain, add water, grow trees, whatever. And that would mean that we would have to find some point during the game loop where we can actually try and bake probes or regenerate probes. And I haven't really figured that out just yet. You could think we're gonna have a day and night cycle as well, so every time the player goes to sleep, you recalculate the probes that needs to be recalculated. But that also means that if the player changes the environment at a certain point close to a probe, you won't see the reflections for that change until the next day. So yeah, we're gonna dive into probes later on as well, but we're gonna have to extend them as well because we want it to work with outlines, right? The DAC shader heavy stuff then? Yeah, it's shader heavy stuff. It's been a while actually. Hopefully we're soon done with the visuals of the water and we can move on to back to some game logic, you know. But yes. And just to summarize, we had it working at the start of the stream, I restructured some stuff and now it doesn't work. So somewhere I did some tiny misstep and now it's eating my time. It's frustrating, but we'll see. And the DAC happens all the time. Yeah, it does. Especially for me. I think I might, if I'm gonna be honest with myself, I might be one of those that like to restructure things a little bit too often. But I think, or what I tell myself, is that it makes it easier to experiment, and I love experimenting. But yeah, sometimes this happens, and yeah. Derek saying, once I learned how to create structs, I didn't work on anything gameplay related for months. Yeah. Love that feeling though, when you find something that just improves the code for your whole project, you know. But what bothers me with this is that we usually find the problem rather quickly, but this time around, I wonder, we introduced previous depth VS. Do we have a problem with this one? Get ray depth. But this, we don't use this one in this solution, so that shouldn't really, that one shouldn't get affect it. Dadak, I agree. I was working on this UI component this week and got it working as intended. Then I refactored it and lost 30 hours trying to figure out why it didn't work again. Damn. It was script execution order problem. Oh, one of the worst errors, I would say. Fucking hate execution order related stuff. They remind me a little bit of like race conditions, you know, when you do multi-threads. Let's get like on that same subject. What is it called? Unity, mono behavior, execution order. Is this for Unity 6.0? Yeah, this one. One should, if one works with Unity, one should pretty much learn this one by heart, right? What's up, Calvino? Race conditions, best conditions. But this one, at the start, when I started in Unity, I had a lot of errors stemming from the fact that I didn't know the exact order of like fixed update compared to whatever yield start coroutine and stuff like that. But okay. Our array is correctly defined. We have step count, step direction, screen point depth difference. If depth difference is bigger than 0, we return 1, otherwise 0. Okay. So we have this method. Depth difference, return. Oh! Yes. We also want to do if this one returns true, it's gonna help a bit. And then we check this. Yeah. Is our jitter too big? Yeah, there we go. We have this artifact still, but I think I'm okay with that one for now. Still though, depth difference. Why do we get this one? Calvino, well, I don't work with Unity, but I work with React, so learning the life cycle was still important. Oh yeah, I guess each each language and each software comes with its own similar problems, right? Luke, Horizon bug, yeah, it looks like it, right? What bothers me with it being a Horizon related bug is that this is the only place we return 1. This needs to be true and this needs to be true. We return false here when we go out of screen bounds or when we have walked the entire array. But I think I'm starting to think that this one is interesting. I think this one is related to this one. Or actually, saturate so at the first point, if we go negative ray direction, which we won't be able to do now because we saturate this one, but we still have this one. So if thickness brings this point beneath the reflective surface, we're gonna return this as a intersection, and that's wrong. So was its thickness right? Yeah, but if we go 0.1, yeah. Okay, beautiful. Yeah, so this is a problem, this is a known problem with this solution. So this solution is our previous solution. It gives pretty good result, pretty good. I think it gives very good performance as well, but we have these artifacts. And as I explained at the beginning, it's because in this solution we have a point on the ray and we go backwards on the ray. Why can't I? There we go. We go backwards on the ray and forward on the ray to calculate a section, and this section is used to calculate the intersection. But what happens when we're at the first point is that we move backwards, so we're actually behind the reflective surface, and in this case what's behind the reflective surface is the ground, so we get an intersection with the ground, which we shouldn't. But that's a problem too related to the old solution. The new solution shouldn't have it, because instead of doing the section like this, we do the section like this. So that means that we have a previous point and a next point, and that's the section we use for the intersection calculation. The only problem being that this solution still doesn't work, and by doesn't work I mean that the result looks like this. This is pretty much the exact, or obviously there's one difference at least, but it's pretty much this, except that point A and point B are replaced with current depth Vs and previous depth Vs. I'm starting to think, so what if we just did this? T minus, is it here we want to do is thickness? No, not, but jitter. I just want to try if this gives the same result as the previous one. Like pretty much I'm wondering if this is the problem. But then again, yeah. Oh, depth bounds, we need that one. The Dak, what would you recommend for learning shader programming? I'm avoiding it for a while, but I should learn it at some point. There exist so many good resources. Is it in relation to Unity, or are we talking some other shaders like GLSL? I wonder, I did send an email a couple of days ago with some recommendations to someone. Let's see if I can find it. Me personally like, let's see, I think these are pretty good resources. And let's see. There we go. I think these are pretty good resources over in Twitch chat. I can post it in YouTube chat as well. And no problem at all. I just clipped it right out of an email I wrote a few days ago. But okay, so yeah, something is extremely wrong here and I have no idea what. So let's just do this. We're going to take this code. We're going to put it here. And we're going to compare it. Point SS. First of all, we send in offset here. So it's step count times step direction. So the same as the offset here. We calculate point SS here, but it's current point here. Yo, what's up, Fluffy? Appreciate the lurk. And no problem at all. Current point, get ray point SS ray offset, get ray point SS ray offset, the same. Then we check, is point within screen bounds, same. Instead of returning false, we return red, but that's okay. Then we do inverse lerp ray point SS, exactly the same. Check this, but instead of returning false, we return blue. Then we do current depth VS. Instead we do 2 points here. Get ray depth VS ray T. Here we add jitter and remove jitter. That's to create the boundary, but we get the boundary here instead. So you can think point A is current point depth. Point B depth is previous depth. We check which one is the smallest and we put that one in A. We check which one is smallest and put them in either X or Y in depth bounds here. So long everything is pretty much the same, right? Then we calculate the scene depth by reading the depth texture. We do it with point SS. Here we use current point SS. It could be, I just need to double check. Float 2, float, bool. And finally, when we do depth difference here, previously we set this one to 1 if this is true, otherwise 0, then we return true. Right now we just return 1 if this one is true. And we do depth bounds X minus thickness, point A minus thickness, scene depth VS, and Huh. I don't see it. But can I see something? Can I figure something out from how this behaves? Yeah, it's something with the projection. It's 100% something with the projection. So this one. Am I overseeing a fact here? So instead of doing the interval by doing minus and plus jitter, now we're going from previous depth VS, we're using the previous point. Does something get screwed up? Like with moving too many steps here. 5, 1, 5, 6. I want to see what happens if we do if abs between current depth VS minus, let's do it down here. If abs current depth VS minus scene depth VS is less than, let's go thickness, return 1. Still, okay. Fuck, do we need previous point SS. Do we want to compare? It's going to be such a relief to find out, if I find out what's causing this. Because what we do now is we take the depth at the current point on the in view space and compare it with scene depth, and we still have a projection error. But we rely on this method for it. Oh. Oh, no change, yeah. But we rely on this method to get this one. We do the same in this solution, and this solution gives us a result without the projection artifacts. Wow. We don't care about this one. Pretty much just removing things until we find feels like we just remove things until we just have one thing left, and that's the error, but we shouldn't need, or we don't want to saturate this one. Linear eye depth, we do it with Z buffer params. That's the correct way, right? Yeah. Current point is a float 2 in this case. What the fuck am I missing? We don't have any issues, warnings, errors. Now I'm starting to think, is this a... I know what it is. I know what it is. And it's so gut... Okay, I found it. And I know what it is. And I hate it. I hate it. Oh, okay. It's this line. 100%. Step count, integer, step direction, float 2. We want to have a float 2 result here, right? But a little wrong definition of offset here. Only gives us one value in X. Okay, much better. Thank you. Jesus. Oh, beautiful. Oh, beautiful. Okay, still some issues, or some artifacts I mean, but now it works. Very good. We care about thickness and we care about step length. Step length should result in a bigger difference between banding. So one, extremely unoptimized I think, but a pretty good result. Banding still bothers me, but that's okay. But we want to, so let's see, if we have a step length of 1, we end up with, we pretty much do the max steps for all the rays, so that's 1,000-ish. We want to land on a step length of 20-ish, I think, yeah, 230 FPS. So we want to have a step length of around 20. The bigger the better for performance. But then of course the bigger we have, the more banding we're gonna get. Hopefully changing thickness here can help us a little bit with the banding. Unfortunately it doesn't help that much. If we go too big, I think we're gonna start seeing, I wasn't expecting this artifact. Don't like these. They're too big. We're gonna add also a sphere, much like we did yesterday. Put it here. Let's put it here, but a little bit further away. Can we get... That's good. I think this gives a little bit worse result than this one, I think. Or we're talking pretty much exactly the same. 200. But this one is quicker, way quicker, I would say. Just by a very quick test. But in this one we have something called jitter as well. That can improve the result a bit, although I think the second pass is going to help us a lot. It's going to remove a lot of the banding, but some of the artifacts I see are still a big question mark for me. If we could get rid of this artifact, that would be perfect. I'm gonna do when we return 1 here, we're gonna return, oops, we're gonna return step count divided by max steps, because when we find a hit, I want to know how quickly we do it. This is not too quick. Alright. Yo, what's up, Fabic? How are you doing today? It's going pretty good. Had spent roughly an hour on a very stupid mistake. But other than that, it's going good. How about you? How are you doing this Friday? What is it? Still morning, I reckon. 10 divided by max. This is still way grayer than I would think. Yo, what's up, Scafer? Yeah, you can start calling me reflection guy now. Although the final goal for the reflection is mainly for the water, but yeah. I'm just gonna do if step count is less than step length. Two times step length. Yes. Yes. Okay, so that's what we have. We find an intersection here on the first step, and we find an intersection here on the first step thanks to this one. I guess we could say fuck it to really. Oh yeah. Really. Okay. Okay, so that's not the only problem we have here, i.e. minus thickness. That's good to know. Yeah, if we could get rid of this, if we can get rid of this artifact, the big white part, and then do some minor, we add a second pass, and then we do some minor try to do something to fix this banding here. We can probably, I think we can fix it with the second pass. Can probably fix this one as well, because we're going to keep track of the point that is closest to be okay here. So we're gonna store like a score here, and so when we do the second pass, we're always going to do the second pass, I think, for all the rays. Now we're going to do it for all the rays that has a score here below a threshold. Fabi, can you take the camera pitch angle into the step distance calculations? Yes, that's definitely something we're going to do later on, or something very similar. I talked about it previously. It's a great idea. What we are interested in is, so it's actually the angle between the view space ray and the screen space ray. So pretty much we want to figure out how closely are the screen space ray and the view space ray aligned, and then we can alter the step length based on that property. It's pretty much a calculation of figuring out like what is the ratio between one step here and one step here. So how much longer is this step than what it's actually seen on the screen, or something like that. But this one bothers me a lot. We can test it if we do 0 on thickness. Yeah, we don't get it. We never get it. Fabik, have you seen Sebastian L video about portals? It might help. I have seen it, but it's been a while. I will definitely take a look at it after the stream and see if I can pick out some good knowledge. If we purely focus on the reflections here now, they look very nice. We can definitely clean this up. Definitely. I don't know, the moon looks weird, so this one, yeah. A moon with default material. And appears to be a little bit closer than one would assume, right? When I see this artifact, all I can think about is this. Oh! Yes. Okay. Can I draw this and make it make sense? Have I been playing with gravity again? Not that I recall, not that I recall. So what can happen here? How could... Depth bound X is the previous point. So if we have the camera here, we have the reflective surface here, we have the ground right underneath. We have a ray like this. We have point 0 here, we have point 1 here, maybe. Probably. It doesn't matter how I draw them. So let's see, what we do then is we take this depth, that's D1. We take this depth, that's D2. And then, so we pretty much shoot a ray here as well. It hits here, so we get this depth. And this is depth compare. And then we check D1 plus minus C less than or equal to DC less than or equal to D2 plus C. D1 minus C. If C is big enough, we end up here, so this one becomes... I don't see how this one can become smaller than this one in any way. This one should always be further away. Yeah, that's okay, that's true. Yes. Okay, that makes sense. So this one, even though C is 1, this one is closer to the camera than this one. So this holds true. And yeah, in this case, this one holds. This one is false, right? If C is, yeah, if C is big enough, if C is big enough, yeah, if C is big enough, this depth offsets down to here, which means that this one is bigger than this one, and this one is bigger than this one, and that's the problem we get. Okay. So it's not only a problem of this one, minus thickness being smaller, it's more of a problem of this one being bigger. What can we do to avoid this happening? Yes, because when we do, yeah, when we do negative here, we basically bring it back here. So negative should be, let's see, we have this artifact, and then we remove. Yeah, maybe this is the only part we care about. 190, 20. Okay. $230 FPS. I'm happy with that. That's before the second pass, though, and I would say we still have some very bad, some extreme banding. Okay. Perfect world, perfect screen space reflections. We could probably go down on thickness here. And these are, what we're seeing here, these are the kind of artifacts that work perfectly together with water. So worst case scenario, we can just run with this, I think. But this is without colorization as well, so yeah, probably want to improve that a bit. Okay, but if we take this, we have a ray hitting here and then hits here, or finds this. We probably want to do a second call, and we are a bit more unforgiving. So if we do 0.1, and we do step length 1. Okay. So 21. So it's this one. We're gonna keep this one, but we're gonna remove this one. Okay, I think we can do this. I wanna define a score system first. So instead of letting this be binary, we want to convert it into some sort of score system. So the closer this one is, or let's see here. Yeah, I think the closer this one is to this one, the better. I think. But I wonder if we also want to do I guess we want to check I think we want to check. Let's see what we can do with that first of all. So let's return lerp between zero thickness maybe, and depth bounds dot y minus scene depth vs. But we want to do inverse lerp. desaturate. But that is going to be us, that is going to give us, I wonder if we want to flip these. So the closer to 0 this one is, the more white we're going to get. Okay. Yes, so this one has a higher value than this one. That's good. These ones are actually, so what this means is that these are false reflections. So i.e. we reflect, what is it, this point, but we're coming in from the wrong direction, if that makes sense. The reflection is coming in from behind instead of in front. So this score we can use. So if we have wrong reflections like this, we probably don't want to, we want to base the color of this, or we want to darken the color of this more towards black, the more wrong it is, I guess. But it's also, I wonder if we can do this. So right now, when we find any point that is true for this, we return. Yeah, that might work. And the more we increase this one, the more. Okay. So if we base the second pass, okay, we can go. Let's be pretty strict with the second pass. See what we get. I wonder if we can go 30. Could we go very rough here with this scoring, and then do the second pass? If we're extremely rough here, I don't like what we're getting here. But then again, if we take the dot product between this ray and this one into account, we can probably do the step. So in this case here, we would step maybe 10. Yeah, we can do a lot of improvements here. So more steps. So what we want to achieve as well is more steps for this angle and bigger steps for this angle, I reckon. But bigger steps here fucks it up as well. Yo, what's up, Smack GDs? What's the latest? Still doing this screen space reflection, but I think we're at a pretty good point now, that's for sure. So let's start by adding a second pass that is pretty damn hardcore. Okay, I'm gonna just clean this up because I think this is the best result we have so far, performance wise and visual wise. Save, stop. Yeah. Maybe want to keep this one around. But we have depth difference. We don't care about depth difference anymore. Ray point SS. We don't care about this one anymore. What we could do is the compiler should, if it can gain some speed, it should move these outside itself. So I don't care about this. I don't care about this. Step direction we want. Delta we want. Smallest depth difference. Yeah, we're gonna have something similar, but not this one. Previous point SS we don't use. Step count we use though, but I want to move it down to here. Current depth VS we use. Previous depth VS we use. Ray length SS we don't use. We defined array. This comment is wrong. We don't care about this method anymore. And here we have it. Way cleaner. So now we can start adding the second pass. Smack the GDs, you should partner up with someone who will work on the actual game and you focus on the technical artistry. So the technical artist part of the sounds pretty good, but I do like, believe it or not, I do like gameplay implementation as well. And we're gonna get to it. Right now it's pretty much like we do a couple of months of gameplay related programming and then we do a couple of months of visuals and then we do a couple of months of gameplay. And yes, I was actually hoping, either me or my son has been sick quite a lot this autumn. I mean, it's cold season, but according to my timeline, I should have been done with the water right now. And what we're gonna do after the water is actually some gameplay related stuff. So I'm blaming the colds, okay? Have you started a GDD? I don't know what that is. The classic wall of flesh, what's up? How are you doing today? Idea make a Wendigo that chases cheaters. I mean, initially it's gonna be a pure single player experience, so if I don't gonna care that much about cheaters. But what is a Wendigo? Ooh, love it. What culture is this one stemming from? Algonquian folklore. So what is it? North America. Pretty much Canada, right? That's pretty cool, actually. So the basis for a lot of the monsters in this game initially was gonna come from Scandinavian folklore. But hey, Canada, Scandinavia, potato, potato. A game design documentation. Yes, fuck yeah, we have a big game design documentation. Yes, we do. Mocads, thank you for the follow as well. Appreciate it. Yeah, I think phase 1 gameplay wise, it's pretty detailed. The game design document. But you know, people like pretty things, I like pretty things, so I like to keep up the visuals as I go. I know, that's the wrong way to do it, but I just can't stand grey boxes anymore. I hate it. Okay, back to this shit. Yeah, I think this is a pretty good score so far. So I'm wondering... For now, we're gonna keep this one if we want to use it as a score later on, but for now I'm just gonna do a break here. We're gonna rename this one to... Fuck, I don't want to rename this one. But I don't really care about this one right now, so yeah, whatever. Thickness. First pass. Default is going to be 0.1. Thickness, second pass. Actually, we could probably rename them lazy pass and detailed pass instead of first and second eventually. Lazy might not be the best word, but whatever. I'm a little bit afraid that by doing a break here, I'm wondering if we want to run the full ray here instead of doing a break. We're gonna lose performance, but we might actually have a case where we find we're gonna find the first intersection, but that might not be the best intersection. So we might find the first intersection here. In the second pass we notice that, oh, this shouldn't be an intersection at all. So when we get to the second pass we just throw it away. What you could do is also once again, it's going to tank performance in certain cases, but if this one is true, we do the second pass here. But that's a loop within a loop. I want to avoid that, but yeah, so let's see. We're going to do some experimentation, see what's the best solution. Or hopefully converge towards the best solution at least. Okay, so second pass is pretty much going to be exactly this, but we don't need to check We're gonna start by not checking this. Let's see here. So if this is true, we're gonna break eventually, but first we're gonna do segment start SS is equal to this is where we want to have segment start previous point SS and end point SS. So we do previous point SS is equal to current point SS, and then we do endpoint SS is equal to current point SS. Break. In fact, do we want to make an array out of this? No, we can still use this array. Okay. I want to try and do step count is equal to 0. Let's put this one up here, and then we do step count plus plus. Let's do plus equals to 1 because we're going to change this one, and then we do save stop plus plus. And then we pretty much want to do float 2 offset. A lot of the same thing we do here, but I'm not gonna reorganize it just yet. I've learned by mistake. We're gonna see how equal this one is when we get to the final product. And then we might create a function or a method or whatever. Current point SS. Get ray point SS. Oh yeah. Offset. Can we do offset is equal to previous point SS plus step count step direction? Yeah, I think that makes sense. Get ray point SS ray offset. We don't need to check this, and we don't need to check this, but we need to calculate this. And here we also want to check if we don't want to check this, but we want to check something similar. So we're going to do float t end is equal to I think we want to define it up here. So within this one we also do t end is equal to t. If t is bigger than t end, break. And then we want to do this. We don't want to do this, but we want to do this, but we can store this one as well. Or actually, can we? No, we can't. So another text read. And then what we want to check here is float depth difference is equal to current depth vs minus scene depth vs, I think. Or yeah, we want to know that the ray depth is behind something. I think this. And then we do if depth difference is bigger than or equal to 0 and depth difference is less than depth threshold second pass. If so, return 1. Otherwise, continue. Current point SS. Oh yeah. Ray.start SS. Ray.end SS. Doesn't really matter what we set them to. Previous point SS is going to change here. Each iteration end point is just going to change before we break. Yeah, we want to define this one up here as well. Okay, so the second one that never turns true. Is it because we break? Do we break too early? No. Still find it weird that... Oh yeah. Okay, we might be breaking too early. Yes, we are. Here, but not here. Yeah, we probably want to do a check here as well. We don't want... maybe. I just want to see what kind of performance loss. Not too bad, but... Okay, so what's happening here? Step count +1. Previous point SS. Does this work? Yeah, I think it does. Current point SS. Should work. Probably not what's wrong here, but I think we want to do it like this. So if the ray is traveling towards an object we want to intersect, we want scene depth to be bigger than ray depth. We want it to be further away, yes. But T end here. Maybe we can't compare it like this. Can we inverse lerp ray current point SS? We should be able to, because we are in screen space and it's linear, so we should be able to do this. Float T, current point SS, if T is bigger than T and current point. Yeah, we can't do this. We can't do this. But we can do step count is equal to or minus equal step length. So we add step length here. This one returns true and we break, so we jump back one step and that's where we start. And then we start adding one there. So it's pretty much walk along this ray like this, and then we find an intersection here. So we jump back to this one and then we step like this. Depending on how we do the exit as well, I think, and the comparisons, like I'm wondering, would it best to step like this or to step here? But I think that's related to how we exit. I think we can make this work. So yeah, we jump back one, and then we don't need. I think this is good. Let's see what we get from this then. Yeah, what we can do is, instead of doing t bigger than n, we do if I guess we can do right, and then we do and step count is, I want to do less than and equal to step count end. Wonder if that is a better way to exit it, but I'm still seeing a lot of things I don't like here. False reflection, yeah. But what the hell is going on here? False reflection. And what if we do step count plus step length? Get this one, that's not good. Step length 20. Fuck, which one is the... I would be hoping for a way better result than this, but that might be thanks to the fact, or actually, I would have guessed, I wonder if we do 1 here. Yeah, I would have guessed that this second pass would get rid of 2 of these. I don't fully understand this result. So what happens here? In the first iteration, maybe we jump to this point here. We get an intersection. The depth here is, or this depth, let's see. For this point, okay. For this point we jump here. Find that the ray depth is way less, or like this, that this point is between this depth and this depth. For this one, we jump here, we find it to be false, and we then jump here and find it to be true. But in the second pass we should be walking here, and the depth comparison should be way if we have the same, yeah, we get 1 here. If we are much more conservative, we find that it's a false. we find it to be a false reflection. But not for this pixel. If we're too conservative, all of them are false. How is my comparison done? Depth difference bigger than 0. No, we want this one to be bigger. Right. This one is false. That's not true. Or is it? 0.01, 2, 3, 4, 5, 6, 7, 8, 9, yeah. 0.01, 2, 3. We don't want to be too harsh here, but this... Also getting some weird true reflections here. That doesn't make much sense. I don't get this. If we take a look at this, and we take a look at .1, in fact, which one is the true one? Is it this the true one? It feels like it is a little bit too far away. Yeah, or is it? Fuck, is this the true one? Ah, maybe it is. I don't know if I buy it. Let's take... Oh, fuck, it is. Alright. Maybe. Okay, but if this is the true one, so we have a long distance there, and then we do this. This is a true one. So this is the true one, right? I don't know what's going on here. This second one here. Why don't we identify it as a false one? Is it actually more correct than this one? Fuck is this? I want to try and do and then we do we don't do break here, we calculate float intersection score, and if intersection score is less than best intersection score, then we do best intersection score is equal to intersection score, and best intersection step number is equal to step count. I don't know. We want to do this we want to base this score on more than just this one, I think. Let's see what we have here. So now we have best intersection score and best intersection step number. Let's just do this for all of them to start with. So step count end. Here we're going to do best intersection step number. And for step count we do best intersection step number minus step length, right? Okay, let's do this. Yo, what's up, Meister K? Currently working on screen space reflections. Not going that good currently, but really? No improvement? So we calculate an intersection score, which is definitely wrong. Meister, what's the use case for water reflections? Yes, but we're going to develop it. So yeah, that's how we ended up here for the water. But I think we're going to use it for a lot of objects that has some sort of, or that is very smooth. So yeah, it's mainly going to be used for water, but I think we have a few other use cases as well. For every object that reflects, so it could be windows, it could be, I don't know, certain parts of monsters, sunglasses, you name it. And we're doing a custom solution, or we're implementing it ourselves because we wanted to work with those goddamn outlines. Yeah. We have an okayish result just yet, or currently I'm just trying to remove the last artifacts that I still see hanging around. So we do a first pass, we find the best intersection point. The intersection score currently is whoa. Intersection score. Basically, we have a scene point that is between two ray points in depth, and I want to find out currently we compare it to this one. Is that okay? Oh, one more thing. Endpoint SS, we only change this one here, T, and we only change it here, okay. I thought, let's take a look at intersection score again, how it looks. Let's just return here. Okay, that explains it. This looks beautiful. This looks like shit. Why is this so good? What the fuck? Why is this so good when we do 40 here? Wow. I get this. Okay. Let's try and figure out why this score becomes so good. Why do we have 1 here? First of all, this one is true. or actually return 1 here. Yes. Yeah, now that's, we're gonna do, I want to change this. Let's return 0 here so we can see. Okay, so this is our intersection scores. A little bit, like, first of all, this one is pretty damn great, I think. This looks kind of good as well. Kind of good. Yeah, this looks like shit. This looks like shit. And the reason for that, I think, is that we only base the score on this one. So I was thinking, I wonder what happens if we take this one let's try some stuff. Let's do float score is equal to lerp between this one and depth bounds y and scene depth vs, but we want to do a inverse lerp here. I want to saturate it as well. So now this is not what we want to do. I was thinking, what if we, this is wrong, but what if we do score is equal to min scene depth vs minus this one. Oops, I don't want to remove it from here. So we get the difference between this one is bigger than this, so we take the difference, and then we take the difference between depth bounds dot y minus scene depth vs as well. So what we end up with is the difference between this one and this one, or this one and this one, depending on if it's closer to this one or this one. Then we want to do an inverse lerp on this score. We want to do it between, like, we want to transfer this score between 0 and 1. 1 being very good. So at most, we could go with pretty big values here, I think. Yeah, I'm not entirely sure about this comparison either. I think we can improve this one a bit. But let's work with it. And let's do inverse lerp between 0 and, yeah, let's do depth threshold first pass, but here we do score instead. Extremely rough. Wowee. Actually, we're going to do it like this. 0.5. No. 0. Plus 0.5 maybe. Okay. And one more thing. Okay, so if this is the score we use, oh yeah. We might have points that are 1 here, best intersection score. Let's just, for now, let's do if best intersection score is not equal to 1, best intersection score, otherwise 0. But then we have this problem. This one annoys me the most, I would say. Extremely good performance on this, but it's still... I don't get it. Yeah, I don't buy this. So pretty much what I'm trying to do, so what we have in place is that we go through the ray like this, we find an intersection here, we jump back to the previous point, and then we do small steps until we find a point that is below our very conservative threshold. But what I'm afraid of is, or what I'm trying to do now instead, is we jump through it and then we find one here that is a intersection according to our sloppy ray march. I'm afraid, like, but I want to try to figure out if we keep walking forward, if we find another intersection, I want to compare these two, and I want to pick this one if it's better according to our score. Because then when we do the small steps, we want to do it from here to here instead. And I don't know if it's the score calculation that is screwing things up, or if it's the comparison. I'm a little bit, because right now we compare it to, how can I draw this in a good way? Yeah, this is, we're currently comparing the, yeah, so we get this point. Let me write the new in red. So this is depth 2, depth 1, and this one right here is depth in scene. And right now we're comparing, yeah, we'll do this. So let me just write it in red here. D1, DS, D2. And I don't know if I'm moving forward under the assumption that this one has more effect on this than it actually does. Like, these two are extremely related, because DS is pretty much the scene depth right behind D2, so that's very relatable, right? D1 though, that is just the scene depth previously. Yo, what's up, Cynic? Hope you're having a wonderful Friday. Long time no see. So this one is pretty unrelatable, right? So doing this comparison might be stupid. But basically it's, we want to find the point where the DS is in front of this one. But then it's quite relatable. It's pretty much, we take DS, let's say that it's in front here, and we put it like this, and we want to check, is this depth bigger than the depth we had here? It makes sense, doesn't it? I'm all good, nice to hear, nice to hear. What are we working on? Yeah, we're doing ray marching. Trying to improve upon a screen space reflection solution, pretty much, so we can use it for our water mainly. Yeah, because here we find out that yes, whatever depth we have now is closer to the camera than the previous ray depth. So fuck, I don't think we want to do this comparison, do we? Do we want to do... Or fuck, do we? You know, when you're a real game dev, when you make custom ray marching shader for reflections instead of making a new material and turning up smoothness up to the max. Yeah, we're down in the outline hole, unfortunately. We want to make this reflection work with our outlines, but also with custom materials. Yeah. Yep. So I definitely agree with that statement, 100%. So if DS is, yeah, if it's bigger than D1, that means that this one is... Yeah, I think we want to do this comparison. It makes sense, doesn't it? And that's the comparison we're doing, but we're also doing it with threshold first pass. So this one right here, we don't want to add it here, do we? Yo, what's up, Ramsey? Yeah, the worst part is this is how we are currently doing it. So there's nothing to try, unfortunately. Or let me rephrase that, we have already tried it. I'm just trying to figure out if it's wrong. But it might still be a bit too... Yeah, what the fuck, it might be a bit too... Yeah, it might be... I'm thinking that it might be a bit too... We're doing too many assumptions with this comparison. Because this could very well be an object that is placed like this. But fuck, no. If it's placed like this, then yeah, if it's placed like this, then this one returns false. I wonder if we just want to do so this tells us that we're behind something. Scene depth vs depth bounds y. Current point SS. Where do we have? Yeah, it tells us that we're behind something, and here I want to figure out how far behind it we are. So let's return a score. I want to return float or inverse lerp between so this is way simpler. We don't care about the previous point in this case. So now we have roughly the same result with a little bit simpler. I think we want to go we're getting closer. I reckon yeah, I want to do this, and then we want to calculate the best score. But then again, Ooh, I like what I'm seeing here. But not this part, but the rest. Let's see, 20. Yeah, we want to go best score later on. So if we can clean this up, maybe we're on to something. Let's see. Ramsey, the stream view just shifted away. One sec, let me take a look at this. Shifted away to what? Am I having uploading problems here? Looks good to me, nice. I have, according to Twitch, the Twitch stats, it should be okay. Yeah, so the problem we have here is something we have been fighting with for a while. And that's if we do comparison like this, we get comparison with what's under the ground as well. That's pretty much why we want to do this stamp check. A is bigger than 0, so this check, and then I wonder I wonder if we want to do this. Cynic, enjoy that food. Unfortunately, I'm going to quit in about 15 minutes, so you're probably not done by then, but have a great weekend, man. Okay, so this result looks pretty good. We have artifacts here, definitely. But hopefully best score can help us here. I hope. So this is pretty much the score we're gonna go with. It's a simple score, right? We do saturate. If score is less than we want as low score as possible here. So if score is bigger than best intersection score, right? If A is big, we're closer to 0. No. If A is small, we're closer to 1. Okay. So yes, we're gonna do with best intersection score 0. If score is less than best intersection score, we do this, we do this, we do and then we do return best intersection score. What do we get from this? Best intersection score is 0 by default. So the closer A is to this one. Oh, yeah, we don't want to do this. No, fuck that. This is everything we shouldn't need to do. I think so. So A is between 0 and depth threshold first pass. Then we do an inverse lerp. If this one is 0, we get 1. If this one is equal to this one, which it can't be, but if we do this, then we get a 0 here. 0 is a bad score. If so, yeah, so if score is bigger than best intersection score, then we do this. Fuck, is this actually... Yeah, okay. I get this. Okay, this is pretty good. I think we can use this for our second pass. What our performance? 220. A bit too rough. 25 here. How? Yeah, 25 and we can do some pretty rad stuff later on here, I think. Something like this. We want this one too. So we want to go. Yeah, we want to increase this one when we go. When we do bigger steps. Oh fuck, look at this. If we do step length 10. Wow. Ooh. If we do step length 10, we have pretty bad FPS, but yeah, whatever. So now we have a best score, best intersection score. Best intersection score gives us also best intersection step number, that's the current step count. Endpoint SS, that's the current point. We get a T end as well, which we don't use. We don't return this one. Instead we do step count end, best intersection step number. Step count is minus step length, so then we start stepping through again. We do it with 1. We get this again for some reason. Why? Okay, we're doing some minor thing wrong. So 1. But what is the performance here? Yeah, it's pretty rough, honestly. Return score. Not score, but best intersection score. Should be able to clean this up real good, I think. Definitely, I'm a little bit worried about this one, but we just need some different settings for that one. Although pretty rough. 23. Yeah, we can fix this. I think we can do if best intersection score is equal to 1, return 0. Oh, if best intersection score is equal to 0, return. What weirds me out here is let's take a look at this. Yeah, let's return this one. Here we have a pretty good intersection score. So we should do a second pass. We should be doing a second pass. We're doing a second pass. And we do depth difference. Okay, let's do abs. I don't see in what world. Okay, I get it. Yeah, if for this to work, we're gonna have to do, or with this logic rather, we would like to do this check. Because we want to, like, if we have a ray that intersects something, we want to trigger it for both, for being on both sides of the ray, pretty much. But if we do it this way, we get intersection with stuff underneath the reflective surface, and that's why we want to introduce the previous point, although I'm pretty sure that we don't want to compare the previous point to the current point's scene depth. I think that's the problem. But then again, with some steep angle checks and big angle checks, we can make this look good enough. But okay, rather, we can make it acceptable but not good enough. So yeah, I guess it's gonna be another week with reflections, but hopefully not too many days. It's time to move on. But I gotta run now. Got some other stuff to do. We'll give this another try on Monday. Thank you so much for watching, everybody, and have a great weekend. Peace.